Namaste students, welcome back to Modern College of Pharmacy, Department of Pharmaceutics. Myself Dr. Atul Pathak. We were discussing biopharmaceutics and pharmacokinetics, factors affecting absorption of a drug. In this lecture series, we were discussing physicochemical properties, how they affect absorption of a drug. In that sequence, now the seventh physicochemical property, polymorphism. Let us discuss and study how polymorphism it affects absorption of a drug. What is polymorphism? When a substance exists in more than one crystalline form, the different forms are designated as polymorphs, and the phenomenon is called as polymorphism. For example, number of drugs, they are available in different polymorphic forms. Like carbamazepine is having 4 polymorphs. Enalapril maleate is having 2 polymorphs. Lamivudine in 2 polymorphic form. Terfenadine in 3 polymorphic form. Many drugs, they exist in amorphous form as well as crystalline form. Among the crystalline form, polymorphism is exhibited by a large number of drugs, especially steroids, barbiturates, sulfonamides. These are the few categories of the drugs where polymorphism is more. Now, these polymorphs can be divided into 2 types. First is enantiotropic polymorph. It is the one which can be reversibly changed into another form due to change in temperature or pressure. Example is a well-known example of sulfur. Second type is monotropic polymorph. It is the one which is unstable at all temperatures and pressure. Example, glyceryl stearates. These polymorphs are chemically not different, but they are different with respect to physicochemical properties of the drug. Like they are different in melting point, solubility properties, and thus different dissolution rate. The stability and driving force for the polymorphic transformations at a constant temperature and pressure is determined by Gibbs free energy, a thermodynamic term, delta G. The internal energy available for the chemical work as portrayed by the equation delta G is equal to delta H minus T into delta S. Here the H term represents enthalpy property like temperature, heat, and S represents entropy, that is the randomness. When these different polymorphs are available with different physicochemical properties, when they will get absorbed and when absorption is dissolution rate limited, then there will be a large change in bioavailability of the drug depending upon which crystalline form or which polymorphic form is used. As you can see in the diagram, a molecule is available in various crystalline forms like polymorphs, co-crystals and their polymorphs, solvents of co-crystals and their polymorphs, solvents of co-crystals of salts and their polymorphs, co-crystals of salts and their polymorphs, solvents of salts and their polymorphs, different salts and their polymorphs, and solvents and their polymorphs. Anyway, we are going to discuss the solvents and hydrates as a pseudo-polymorphism as a next physico-chemical property. At that time, we will discuss solvents and hydrates in detail. Now coming to the polymorphism, how it is going to affect absorption and bioavailability of a drug. Now consider an example of a drug which is having two polymorphic forms, form 1 and form 2, which is represented with two different colors here in the diagram, but they are having different solubility properties. Form 2 is more soluble than form 1. So when these two forms, it will get dissolved and get transported through the intestinal membrane. When it crosses the membrane, at what rate they will cross this membrane is again an important point. Then what will happen to these two polymorphic forms of a drug with respect to the dissolution and solubility limited absorption? For example, in case of chloramphenicol palmitate, you can see in the diagram the concentration versus time profile. In that you can see the form 2, which is having better solubility, is showing better results as compared to the form 1, where you can see the oral absorption is a challenge, is limited as compared to the form 2. With respect to the permeation, that is gastric emptying or permeation limited oral absorption, the same thing, same two different forms which are having two different solubility properties. For example, ranitidine hydrochloride, the oral absorption is not that much hampered. Now from this, what we can understand, that the dissolution behavior of the polymorphs, if we want to rate it with respect to the dissolution properties, various polymorphic forms, the amorphous form is having better dissolution as compared to the metastable form, and then as compared to the stable form. The example is, here you can see the unstable polymorphic forms, they are not useful in the design of a dosage form because of their quick conversion to the stable form. Metastable crystals are in a higher energy level than the stable form. Hence, they exhibit low melting point but high solubility. These show better absorption and more therapeutic efficiency. Coming to the effect of polymorphism on bioavailability. If the absorption of an active ingredient in a drug through the GI tract is dissolution rate dependent, as we have seen this in the diagram, then polymorphism is an important pre-formulation tool. Example, ritonavir form 1 is more soluble form in comparison with form 2, which is thermodynamically stable but less soluble than form 1. It is going to affect the bioavailability for the drug. There are some examples we are going to study with respect to the polymorphism. A very popular example we are discussing here, chloramphenicol, which exists in three crystalline forms A, B and C. At normal temperature and pressure, A is a stable polymorph as compared to B, which is metastable polymorph, and C form is unstable. So it is going to affect the physicochemical properties and further absorption of a drug. Second example is the more soluble and rapidly dissolving amorphous form of novobiocin was readily absorbed following oral administration of an aqueous suspension to the humans. Next example is the faster dissolution of anhydrous form of ampicillin as compared to the trihydrate form, which is giving slower dissolution. Chloroform solvate of griseofulvin has improved gastrointestinal absorption over the anhydrous form of griseofulvin. Coming to the applications of polymorphism, we have to remember these 3 points. The knowledge of solid state properties of the drug helps in avoiding problems during the manufacturing. So during the pre-formulation study itself, you should study the different polymorphic forms of the drug and their physicochemical properties. The polymorphism in the drug, it helps formulation scientists in the developing a quality drug product, better drug product. Polymorphism also helps in ensuring maximum therapeutic action from the drug, preventing loss of material and achieving better bioavailability of the drug. Now you can refer this polymorphism different examples by using a textbook, Biopharmaceutics and Pharmacokinetics. We have completed today the very important physicochemical property of a drug, that is polymorphism, how it affects absorption of a drug. Thank you, students. Keep learning. Happy learning.